In this video, I'm going to explain about the MPLS LDP inbound filtering configuration in iOS XR. First, let me explain what is the meaning of MPLS LDP inbound filtering. You know that LDP accepts labels as remote bindings for all prefixes from all peers. This is the default behavior. LDP operates in liberal label retention mode, which instructs LDP to keep remote bindings from all peers for a given prefix, for example. For security reasons or to conserve memory, you can override this behavior by configuring label binding acceptance for set of prefixes from a given peer, LDP peer. The ability to filter remote bindings for a defined set of prefixes is also referred to as LDP inbound label filtering or label acceptance control. It means that in this scenario, router 1 only needs to have or to keep the labels for the loopback 0 of the router 1, router 2, router 3, and router 4. It means that router 1 doesn't need to accept labels for 10.1.2.0/24, 10.2.3.0/24, and also 10.3.4.0/24 from router 2, and also router 2 from router 1 and router 3. We need only to keep the loopback zeros loopback received from other remote neighbors. How we can configure the MPLS LDP inbound filtering in iOS XR? It is very easy. Let me show you. As you can see, in this scenario, we want to configure the LDP inbound filtering. You know that we need to go to MPLS LDP and then address family IPv4 and then label. Until here, actually, it is same as outbound filtering. But in outbound filtering, we need to use the local keyword. Why? Because we are working on the local labels, okay? Because we talk about which label should be advertised. But here, we use remote. Why? Because we are working on the labels that we receive from our remote neighbors. And then, which labels should be accepted? You should say from LDP ID, this is the LDP router ID, and then LDP, this is the label space, always is 0. And for ACL means from this peer, from this LDP ID peer, I accept only the labels for networks accepted or permitted by this ACL. It is very easy. For example, in the XRV1, I want to configure this ACL IPv4 access list permit and then IPv4 192.168.254.0/24 any and then MPLS LDP. After that, address family IPv4, okay, and then we need to use label and then remote. After that, accept, okay. You know that we are working on the label that we receive from our peer router 2, and the LDP ID of router 2, or actually we can say this is the include LDP router ID colon label space. We need to use this command from 192.168.254.2 colon 0, okay, for A. That's it. This is the configuration we need in XRV9K1 or briefly XRV1. That's it. Let me show you first the LDP or binding table or LIB table in the router 1. We can use do show MPLS, then LDP, then binding. As you can see, we received labels from the router 2 okay, for the actually connected networks 10.1.2.0/24 means for the prefixes that we have in the links between the routers 10.2.3.0/24, 10.3.4.0/24. We learned for all of them labels from the router 2 and also for the 192.168.254X networks. But now I'm going to copy this configuration into the CLI of the router 1. This is for router 1. Okay, here we need to use IPv4 access list, then the name of ACL, IPv4 access list A, then permit, and after that we can copy again these commands here in the router 1. That's it, and then commit the configuration. After commit, you can check the MPLS LDP binding table or LIB table again. Show MPLS LDP binding. As you can see now, for 10.1.2.0/24, we don't have any label from the router 2. Also for 10.2.3.0/24, no remote binding. Also for 10.3.4.0/24, no remote binding. But for 192.168.254.1, 254.2, 254.3, 4, for all of them, we receive labels from the router 1, from router 2. Now, actually, let me configure same as this configuration for router 2. Okay, it has more effect because router 2 will receive many labels for these networks from two actually neighbor, many labels from two neighbor, router 1 and router 3. Here in router 2, you need to configure same ACL, but you should say from 192.168.254.1 colon 0 for A, and also again from 192.168.254.3 colon 0 for A, because we have two neighbor. Before this configuration, in the router 2, you can check LIB, do show MPLS LDP binding. You will see, for example, for 10.1.2.0/24, we have two labels received from router 1 and router 3, and also for other networks. Okay, now let's copy this configuration into the router 2 CLI. In the router 2 CLI, we can copy these commands and then commit. Okay, let's check, do show MPLS LDP binding. As you can see, we need to wait some second. Do show MPLS LDP binding. As you can see, for 10.1.2.0/24, we don't have any label received from the router 1 or router 3, and also for 10.2.3.0/24, and also for 10.3.4.0/24. But for other networks, we receive labels from both of them. You can configure different ACLs, okay? But in this scenario, I'm going to show you how we can do the same policy on all routers. Again, in the router 3, XRV3, I'm going to copy this configuration only. You should say from 192.168.254.2 and 254.4. Okay, means router 2 and router 4. That's it. And again, we can copy this configuration into the XRV3 CLI and commit it. Okay, and after some second, do show MPLS LDP binding can show us after some second. You need to wait some second. We expect that in the next show command, we will not have these these entries. Again, do show MPLS LDP binding. Yes, as you can see, we don't have any label for those networks. And also finally, in the XRV4, again, I'm going to do the same command from 192.168.254.3 only here, and that's it. In the router 4, this is the router 4. Actually, now we can configure the LDP inbound filtering and also LDP outbound filtering. You can define from which peer you want to receive which label for which networks, and also which labels should be advertised in outbound filtering to a specific peer. Now, do show MPLS LDP actually binding can show us that we don't have any label for these networks. Don't forget, If you want to see the peer ID or LDP actually ID, you can use show MPLS and then LDP and then neighbors. Here you have this information, peer LDP identifier 192.168.2542:0. This is the LDP router ID and this is the label space, and always we use label space 0.